Bismillahirrahmanirrahim. This video is about Norton equivalent circuit, and here we'll be solving practice problem 10.10, and this is on the request of a student. So let's just recall what is Norton's circuit. You can see this is the current source, and this current source is known as I Norton, and then in parallel we have a impedance called Z Norton. So this is the equivalent circuit of Norton, and we'll be using this circuit. Okay, now the problem here is determine the Norton's equivalent circuit for the figure, so this one, as seen from the terminal AB. So this is AB terminal. So from here left is our Norton equivalent circuit, and then we have to use the equivalent circuit to find current I0. So this current I0 is through this portion which we'll call load. So the first step is that we separate the load, and then we'll find the Norton impedance and Norton current from this one. So to find Z Norton, we got to remove the source. We short circuit the voltage source and open circuit the current source as shown here. Shorted the voltage source, open the current source. And now this is the impedance. And you can see this one is in parallel with the other branch. So we can say that Z Norton is 4 plus J2, which is this, in parallel with 9 minus J3. So 8 plus 1, 9 minus J3. And solving, we find this to be the value of Zn. And now we'll try find the current, Norton current. For that we'll short circuit the two terminals, and the current through this is known as the Norton current. Now to find this, we'll take help of the mesh equation. Okay, now you can see from the circuit that this is the current source between two meshes, and therefore this forms a super mesh. Also note that we had marked the current directions I1, I2 and I3, and now we'll write the equation for the super mesh first. So for the super mesh, we're starting from here minus 20. Here it will be 8I1 minus I3. So 8I1 minus I3. Then we come here because this is now we have as if we have disconnected the current source. So we'll follow this loop for the super mesh. So it is 1 minus J3 multiplied by I2 minus I3. So I2 minus I3. And you can simplify this, I hope. You can collecting the like terms. So this is our equation number 1 for the super mesh. And for the mesh, we write two equations actually. One is the KVL equation, and other is the KCL equation. Now at node C, this point I have named C. So at node C, we'll write the KCL equation. And what is the KCL equation at this point? Current I1. This I1 is entering, the 490 is entering, and I2 is leaving. So we can write I1 plus 490 is equal to I2. And from here we can write that I1 is I2 minus 490. So this is our second equation. And now we'll write third equation for this mesh 3. We are starting from here, so 4 plus J2 I3. Then we come here, so 1 minus J3 I3 minus I2. This is I3 and this is minus I2. And similarly here 8 I3 minus I1. So 8 I3 minus I1, and simplifying we collecting the like terms. This is our third equation. Okay, so we had these three equations, and we'll try to solve. Our aim is to find current I2 in the second loop, which is equal to In. Okay, now adding 1 and 3. 1 and 3, if you add, you see this term gets cancelled. This also gets cancelled. So all we get is this one. And from here we can find I3 to be 4 minus J2. So this is our equation number 4. Putting value of I1 and I3 from equation 2 and 4. From here I1 and from here I3 into equation 1. In this equation we are putting. There are many other ways you can solve, but this I found to be easier. So putting the values, now you see 8 I1, so we put this value of I1. Similarly, this remains same. 9 minus J3 I3, so we put this value of I3, and solving, we come up to this point, and from here we can calculate I2, and I is 8.396 angle minus 32.68. So as I mentioned that I2 is actually I1, and therefore we can, In, therefore we can say that In is equal to 8.396 angle 32.68. So now that we have found In, so now that we have found the value of In and Zn, so this is our Norton equivalent circuit, and with this we will now connect the load which we had disconnected, this load. And so we have connected the load, and this is the current of interest I0 that we have to find. Now this is simple, you can see this is the current and there are two branches, so current is dividing into two branches. So by current division rule, by CDR, current I0 will be the total current, so this is the total current, divided by total impedance, so this one plus this one, and multiplied by opposite arm. We are interested in this, so we'll multiply by the opposite arm, and is solving this. This is the answer, which is same as given in the book. So I hope you were able to follow this and will be able to solve this type of a problem. Thank you.